Okay, you attempt. I'm going to attempt to go through these two worksheets. So the first one that I want to do is the one where we're drawing out atoms. We're drawing out ions and we're turning them into atoms, which is the process. This helps you understand half equations. The first bit is a recap from last lesson. If I'm talking about this, I need to remember panic, which is how I remember the electrodes. So positive anode. So here this has got a positive and a negative on the battery. If you have a look there, you can just about see it. So positive anode, so this is the anode, negative is cathode. And remember, the ions are the opposite to the odes. So the cation is positive and is attracted to the cathode. So this is the cation, and this is the anion. And the thing to remember there is that an doesn't mean positive and cat doesn't mean negative, because it's different from the ions than the odes. But if you remember panic, that is how you remember the electrodes, and the ions are the opposite. I think that this is supposed to be the electrolyte. Yes, that's it. So I've done all of those. This is the electrolyte. That's that. The next thing, it says complete the dot and cross diagrams and accompanying half equations to show how positive ions are converted into atoms. We've then got some for negative ions, and then we've got a few half equations at the end. So we're talking about how we turn positive ions into atoms. Well, lithium, if I look up, you need your periodic table to answer these. If I look up lithium in the periodic table, the smaller of the two numbers is 3. So lithium has 3 electrons. That's lithium atom. So here I've got to have 3 electrons. That's lithium atom. But it starts off as a lithium ion, and that's going to have 2 electrons. And in the past, we've talked about how we turn lithium atom into lithium ion. But in the half equation, we want to go from the lithium ion, which has got a 1 plus charge. So I draw it in square brackets with a plus. I want to go from lithium plus to lithium, and that's what happens there. So sodium, we know, is in group 1. It's got 1 electron in its outer shell. If I look up the atomic number of sodium, it's 11, so it's got 11 protons and 11 electrons. Well, those 11 electrons in sodium metal or sodium atom are 2, 8, which gives me 10. And it's in group 1, so it's going to have 1 electron in its outer shell. There it is there. Now, obviously, when it forms the ion, it's only got 10 electrons. It's lost that 1 electron in the outer shell. And so I draw out my 10 electrons. It's a stable ion, so it's got a full outer shell, but it's lost that 1 electron, so it has a 1 plus charge. So this is plus an electron. And I go from Na plus an electron to Na, sodium ion to a sodium atom. Magnesium forms a 2 plus ion. I look at magnesium and it's got an atomic number of 12. So it's going to lose those 2 electrons and it's going to have 10 electrons in its in the ion and 8 electrons in its outer shell. So that again if you look, the electronic structure of magnesium 2 plus is the same as the electronic structure of sodium plus, but magnesium forms a 2 plus ion. That is because in the ion it has all of those electrons, plus in the atom it has all of those electrons plus an extra 2. And I can draw those there. Can you still see this? Yes, you can. So the equation then becomes Mg2 plus 2 electrons goes to give Mg. Okay. And the last one, aluminium. Aluminium has 13, so this time it forms a 3 plus ion because it would have a 10. Let's draw the 10 with the 3 in its outer shell. 1, 2, 3. And it loses those 3 to just give me 8 in its outer shell, 10 electrons altogether, but it has a 3 plus charge, and this is, and therefore it gains 3 electrons to become aluminium metal, aluminium ion, Al3 plus 3 electrons goes to give aluminium metal. So those are the half equations for forming metal atoms from different metal ions. Now all of those involve gaining electrons, so all of those are reduction. Okay, reduction is gain, rig. So these are all, I'm going to write that, this is reduction. There we go, all of those are reduction. Now if we look at negative ions, it gets a little bit more complicated, because with a lot of our negative ions, the atoms that they form go around in pairs. So we've got the halogens, chlorine, bromine, iodine, and oxygen as well. And all of those go around in pairs because the formula of chlorine is Cl2, the formula of bromine is Br2, the formula of oxygen is O2. So because all of those atoms go around in pairs, then I need to take 2 of the ions. So fluorine, if I look at fluorine, it's got an atomic number of 9. So it's got 2 and then 7. 1, 2, 3, 4, 5, 6, 7. That's fluorine. Now fluorine gains an electron. There's my electron that it's gained, and it becomes a fluoride ion with a 1 minus charge. Okay, that's my fluoride ion. Now what happens is that my fluoride ion loses an electron, so it's minus 2 electrons because I've got 2 of them, to become the fluorine with 7 electrons in its outer shell. So each fluorine loses 1 electron. So and it will have 7 electrons in its outer shell. But it covalently bonds to a second fluorine. So this fluorine also has 7 electrons in its outer shell. So it's that, and the equation for that is 2 F minus goes to give F2, this is the electronic structure for fluorine, F2, plus 2 electrons. Now, they've done it here with the 2 electrons being added to the right hand side. This gets very confusing, and students quite often don't see this, but that half equation is exactly the same as writing 2F minus 2 electrons goes to give F2. It's just like in maths. If I've got plus 2 electrons on this side of the equation, it's exactly the same as having minus 2 electrons on that side of the equation. And it doesn't matter which way you write it out. Sometimes you'll see it written out like that. Sometimes you'll see it written out like that. I prefer to always keep the electrons on the left-hand side because it's easier to see whether it's been oxidized or reduced. Oxidation is loss. I can see it's minus 2 electrons, and that makes more sense to me. But here, if it's added 2 electrons on the right hand side, then it's lost 2 electrons on the left hand side. So it is actually oxidation. That's something to just watch out for. So again with chlorine has 7 electrons in its outer shell. So when it's chloride, the ion, I've got to make the ion on the left-hand side. Let's draw out the atom first of all. So chlorine has 7 electrons in its outer shell. That's its 7 electrons there. I'm just going to draw the outer electrons actually. Makes it a bit easier. So this chlorine also has 7 electrons in its outer shell. And those are the atoms. And the atoms are found in a covalently bonded diatomic molecule of Cl2. Now they are formed from 2 of the ions. Now a chloride ion has 8 electrons in its outer shell because it's gained 1 to form a minus charge. So that's my chloride ion. It's got a negative charge. And the half equation then becomes 2Cl minus goes to give Cl2 plus 2 electrons, because I've got plus 2 electrons there, or minus 2 electrons from that side. Now oxygen is just about as difficult as you're ever going to get. Oxygen has 8 electrons in its outer shell. It has 8 electrons overall, so it has 6 electrons in its outer shell. Now it actually forms a double bond, so I've got 2 electrons from this atom in the double bond, and it's got 2 there. So that's my 8 electrons for one oxygen. If I draw the 8 electrons for the other oxygen, it's 6 in the outer shell and 2 there. So that's my O2, and that's O double bond O. Okay, now in an oxygen ion, instead of having 6 electrons in the outer shell, it will have 8 electrons in the outer shell, so it just forms 8 like this, doesn't it? This is oxide ion, and it's 2 minus. So if I've got 2 lots of 2 minus, then overall I need to lose 4 electrons. So it's 2O2 minus goes to give O2 plus 4 electrons. A little bit tricky that, but I'm sure you will have got there. quick swig of coffee. Now, half equations, complete the half equations below. Remember, positive metal ions add electrons, negative non-metal ions lose electrons. Non-metal ions almost always go around in pairs. So Pb2 plus 2 electrons goes to give Pb. 2 Br minus goes to give Br2 plus 2 electrons. V5 plus, this is vanadium metal, it's going to give vanadium metal. This is a vanadium ion, and it's got a 5 plus charge, so it's got to gain 5 electrons. Plus 5E minus goes to give vanadium. This is manganese, and it gains 4 electrons, so it's got to be Mn4 plus 4 electrons goes to give manganese. This is a nitride ion, which goes around in pairs to give nitrogen. Now, each I need 2 lots of my nitride ion to make N2, and that gives me 2 lots of 3 minus, which gives me 6 minus. So I've got to lose those 6 electrons to give my neutral N2. So it's going to be plus 6 electrons on that side. Oh, sorry, you haven't been able to see that. I'll just move that up. Right. I think what I'll do is I'll do a second video for the second worksheet, because otherwise these videos get a bit too long. Hopefully you've understood that.